The speed of light, 300 million meters per second, give or take. Absurdly fast. Nothing goes faster. Everyone knows this. But have you ever stopped to ask why? What's actually preventing you from going faster? Is there a wall, a barrier, some cosmic police officer saying, "Stop, that's fast enough"? No, there's something much stranger going on. Most people hear speed of light is the cosmic speed limit, and they nod. Sure, Einstein said it. Must be true. But that's not understanding. That's memorizing. When you actually dig into why nothing can exceed this speed, when you really ask what's stopping you, you find something extraordinary, something that completely reshapes what you think space and time are. The speed of light isn't really about light at all. It's about the architecture of reality itself. Let me show you how we got here. Start here. An apple falls from a tree. You've seen this. Everyone has. It accelerates downward, gains speed as it drops. Measure it carefully. After 1 second of falling, it's dropped about 5 meters. After 2 seconds, 20 meters. The distance increases with the square of the time. That's acceleration. Gravity pulling it down. Now look up. The moon, hanging there in the sky, not falling, just staying up there, going around and around. But is it really not falling? Think carefully. If you put the moon somewhere in space and left it motionless, what would happen? Gravity would yank it straight down to Earth. No question. But the moon isn't motionless. It's moving sideways, perpendicular to the pull of gravity. And while gravity pulls it inward, that sideways motion carries it forward. So it falls, but it falls in a curve that matches Earth's curvature. It keeps falling and keeps missing. That's an orbit. Nothing holds the moon up. It's in continuous free fall, constantly missing the Earth because it's moving sideways fast enough. Newton saw this, and he asked, how much is the moon falling? The moon is about 400,000 kilometers away. We're standing 6,000 kilometers from Earth's center, so the moon is roughly 60 times farther out than we are. Newton wondered, what if gravity weakens with distance? What if it follows a precise mathematical rule? If you double your distance, gravity becomes 1/4 as strong. Triple the distance, 1/9 as strong. The inverse square law. If that's true, at 60 times our distance, gravity should be 1/36 as strong at the moon. So if an apple falls 5 meters in 1 second here on Earth, the moon should fall 5 meters divided by 3,600 in 1 second. That's about 1.4 millimeters. Can we check this? Yes, we know how far away the moon is. We know how long it takes to orbit. We can calculate exactly how much it's falling toward Earth every second, just from its orbital motion. The numbers match perfectly. This wasn't guesswork. This was prediction. Newton connected two completely separate observations, falling apples and the moon's orbit, with one mathematical law. And suddenly, the universe made sense in a new way. Newton's law worked beautifully. Planets moved in ellipses, just as Kepler had observed but couldn't explain. The tides made sense, 2 per day instead of 1, because the moon pulls different parts of Earth by different amounts. Everything fit. As instruments improved, astronomers tested Newton's law more carefully. They watched Jupiter. Jupiter has moons, lots of them. They orbit Jupiter just like our moon orbits Earth. By tracking these moons night after night, year after year, you can predict exactly where they should be at any moment using Newton's law, and something strange showed up. The moons didn't appear where they should be. Sometimes they were early, sometimes late. The discrepancy was consistent, about 16 minutes off at the extreme. 16 minutes. That's not a small error. Something was wrong. But here's the interesting part. The moons appeared ahead of schedule when Earth and Jupiter were close together, and behind schedule when they were far apart. A Danish astronomer named Rømer noticed this pattern in 1676, and he made a brilliant leap. What if the problem isn't Newton's law? What if the problem is that we're seeing the past? When you look at Jupiter's moons, you're not seeing them as they are right now. You're seeing them as they were some time ago, because light takes time to travel from Jupiter to Earth. When Jupiter is near us, light takes less time to arrive. When Jupiter is far from us, light takes longer. The moons aren't early or late. We're just seeing them at different delays. Römer used this to calculate how fast light travels, first time anyone had measured it. And it wasn't by shining a light and timing it. It was by trusting Newton's law of gravity and figuring out what else had to be true. This is important. When you have confidence in one law, you can use it to discover others. The discrepancy didn't mean gravity was wrong. It revealed something new about light. This is how science accelerates. Each discovery becomes a tool for the next discovery. Newton gave us gravity. Römer gave us the speed of light. And that number, that finite speed, would eventually break open the entire structure of space and time. We're still riding that wave 4 centuries later. So now we know light has a speed, finite, measurable, about 300 million meters per second. But once you know this, once you start measuring light carefully, you notice something deeply wrong. The speed never changes. Stand on the ground, shine a laser, measure the speed of light coming out, 300 million meters per second. Fine. Now get in a spaceship, a very fast spaceship. You're moving at half the speed of light. Aim the laser forward in your direction of travel. What speed should you measure? Common sense says the light should be moving faster now. You're moving forward at half light speed, and you shoot light forward at light speed. So the light should be traveling at 1.5 times light speed. But it's not. You measure it. Still 300 million meters per second. Exactly the same. Maybe you made a mistake. Try again. Go faster. 90% light speed. Shoot the laser forward. Measure 300 million meters per second. Again, this makes no sense. In everyday life, speeds add. You're on a boat going 10 meters per second. You throw a ball forward at 5 meters per second. The ball moves at 15 meters per second relative to the water. That's how motion works. Except light doesn't do this. Light always moves at the same speed relative to you. No matter how fast you're going, something is very wrong with our understanding of motion. Einstein figured it out, and the answer is so bizarre that it still feels wrong even when you understand it. Your intuition about space and time is completely mistaken. You think space is fixed, a rigid stage where events happen. You think time flows uniformly for everyone, 1 second per second everywhere, always. None of that is true. Space can compress, time can stretch, and they do constantly to keep the speed of light constant for every observer. When you move faster, your clocks run slower, not because they're broken, not because something's wrong with the mechanism, but because time itself is passing more slowly for you, and lengths compress in your direction of motion. Not because things are physically squished, but because space itself is shorter when you're moving through it. These aren't illusions. They're not tricks of measurement. They're real changes in space and time, and the amount they change is exactly calculated to make light always travel at 300 million meters per second relative to you, no matter how fast you're moving. The universe contorts space and time, bending and stretching them in precisely the right way to preserve the speed of light. Let me say that differently. The speed of light isn't just a number that happens to be the same for everyone. It's a structural property of the universe. Space and time are woven together in such a way that this speed must be constant. Now watch what happens when you try to go faster. You're in a spacecraft. You fire your engines. You accelerate. You're moving at half the speed of light now. Fire the engines again. Accelerate more. Now you're at 90% light speed. Fire again, 99%. Again, 99.9%. You keep firing the engines, but you're barely speeding up anymore. What's happening? The closer you get to light speed, the more resistance you feel. Not friction, not drag, something else. Your mass is increasing. Well, not exactly. Your rest mass stays the same, but your inertia, your resistance to acceleration is growing. The faster you go, the harder it becomes to go faster. This is relativistic mass, and it approaches infinity as you approach the speed of light. To actually reach light speed would require infinite energy, which you don't have, which you can't have, so you can never get there, not because your engines aren't good enough, not because you ran out of fuel, but because the universe itself prevents it. Light can go that fast because photons are massless, zero rest mass, and massless particles must travel at light speed. They have no other option. But anything with mass, you can get close. incredibly close. 99.9999% of light speed, but not all the way. The universe has drawn a line and you cannot cross it. So here's the question that probably bothers you. Why? Why is there a speed limit? Why did the universe pick this particular speed? Why not twice as fast? Why not no limit at all? And here's the answer that nobody likes. There is no deeper reason. The speed of light is not a rule imposed on the universe from outside. It's a consequence of the way space-time is built. Space and time aren't separate things. They're dimensions of a single structure called space-time. And space-time has geometry, properties, rules. One of those properties is a conversion rate between space and time. That rate is the speed of light. It's not that light is special. It's that space-time itself has a maximum propagation speed for causality, for cause and effect, for information. Light travels at that speed because photons have no mass. But even if light didn't exist, the speed limit would still be there. It's built into space-time itself. Think of it like this. In everyday life, you think of space and time as separate. You move through space while time flows forward, independent dimensions. Wrong. You're always moving through space-time, always, at a fixed rate. But that motion is split between the space dimensions and the time dimension. If you're sitting still in space, all your motion is through time. You're aging at the maximum rate, 1 second per second. But if you start moving through space, you have to borrow some of that motion from the time dimension. You're now moving through space, which means you're moving through time more slowly. The faster you move through space, the slower you move through time. At light speed, all your motion is through space. None is left for time. Time stops. That's why photons don't age. From a photon's perspective, emission and absorption happen at the same instant. The photon experiences zero time. You can't go faster than light because you can't have negative motion through time. That's the wall. That's the limit. This isn't philosophy. This isn't speculation. We've tested this thousands of times. Particle accelerators. We accelerate electrons to 99.9999% of light speed, and we measure their mass. It's increased exactly as predicted. The closer to light speed, the more energy required for the same acceleration, exactly matching the equations. Satellites, they orbit Earth at high speed and in weaker gravity. Both effects change the rate time passes for them compared to us. Muons, cosmic ray particles created high in the atmosphere. Their natural lifetime is 2 microseconds. They should decay long before reaching the ground, but they're moving at close to light speed. Time dilation extends their lifetime. From our perspective, they live longer. From their perspective, the atmosphere is thinner due to length contraction. Either way, they reach the ground, we detect them. Exactly as relativity predicts. Atomic clocks on airplanes, flown around the world and compared to ground-based clocks. Time difference measured in nanoseconds matches predictions perfectly. It's not theory, it's engineering, it's experimental fact. So let's step back. Why can't you go faster than light? Because space-time has a maximum rate for cause and effect. That rate is what we call the speed of light. Not because light is magical, but because space-time itself has this fundamental limit built into its structure. Going faster would mean going backward in time, creating effects before causes, breaking causality. The universe doesn't allow it. The speed of light is the speed at which now propagates, the speed at which changes ripple outward, the maximum rate of information transfer. And this whole story, this entire framework, came from a chain of discoveries. Newton watching apples fall and the moon orbit. Reaumur watching Jupiter's moons and noticing timing discrepancies. Einstein realizing light speed is constant and working out what that means. Then decades of experiments confirming it, each test more precise than the last. That's the avalanche. Each discovery enabling the next. Each insight opening new doors. 400 years of continuous progress. And it's still going. We're still discovering, still testing, still pushing deeper. The speed of light is not just a speed limit. It's a window into the fundamental structure of reality. It tells you that space and time are flexible, that they bend and stretch, that they're two aspects of a single thing, that motion through space is motion through time. It tells you that the universe has architecture, rules, boundaries. You can't go faster than light because light isn't really going anywhere. It's moving through space-time at the rate space-time allows. The maximum rate causality can propagate. And everything with mass approaches that limit but never reaches it. Time slows down. Space contracts. Energy requirements skyrocket. All of it to preserve this fundamental constant. When you shine a flashlight, when you see light traveling, you're not just watching photons move. You're seeing the structure of the universe reveal itself. You're seeing that space and time are woven together, that there are limits, that the cosmos has rules, strange rules, counterintuitive rules, rules that break your everyday experience, but rules that work, rules that predict, rules that we can test and confirm over and over. That's physics, not comfort, not intuition, truth. The speed of light is the speed of causality, the speed at which now becomes then, the speed at which the future becomes the past. And you can't go faster because there's nowhere faster to go. Reality itself has a maximum rate, and now you know why.